Hi, welcome to another episode of iTutorials. My name is Prince Owusu, a level 200 business admin student, and I'm here to take you through multiple linear regression. So at the end, you get to know how to solve it to get your 20 marks, which is just simple. You don't need to stress yourself about the other questions too. So with this one, with a multiple linear regression, you will go through all these steps and then you get your 20 marks, and it's just simple. The first thing that you have to do is we have the multiple linear regression model. So the model is given to us like this. So this y naught represents a dependent variable. And you see this beta naught represents a constant or intercept. And then we have our beta 1 and then beta 3 or beta 2. These three represent the coefficients. And also we have the x1, x2, s3. They are the independent variables. And we have the EI, which is the error term. So with this one, the way you do, whether you get beta 1, beta 2, beta 3, and then beta 4, the question will determine based on the number of items or number of occasions that they want you to work on. So when you see a beta naught, or sorry, when you see a y naught, it means what's dependent variable, and then we have a beta naught, which is what a constant or intercept in the question. That's how they will give it to you, whether a constant or intercept. And then you have your b1, b2, b3, which are I have explained. So with this one, the beta 1, beta 2, beta 3, and x1, x2, s3, you will get it the way the question will be given to you, or how the question will demand from you. So you see this one, the question can tell you to work on 4 things or just 2 things. So if it's 2 things, then you get what? You get your beta 1 and then what? Beta 2 only. But if it's 4 things, you get beta 1, beta 2, beta 3, beta 4. And you get the x to be also what? 4. So this is the first thing that we have to do, this model. So after getting this model, then you come to the second one, which is what? Interpretation of variables. What variables are we talking about? We are talking about what? The independent what? Variables. So the independent variables will be given to us in the what? In the question. So example, we have what? The b naught, which is what? The intercept. So the intercept, example, let's say the question has been given to us, which we have the intercept or the what? The constant to be 0.14. So with this 0.14, we have to what? Interpret it. So if you want to interpret it, we interpret it by what? Saying this is the variable of the dependent variable when all the independent variables are what? 0. Now this is the what? The dependent variable, and this is what we are talking about, which is what? The b naught. So these are the what? These, the b1, b2, b3 are what? The independent variables. So if we have something like this and we have the b naught to be what? 0.14, the rest, and we have the beta 1 and then beta 2, beta 3 to be 0. It means 0 times the x1, 0 times the x2, 0 times the what? S3, and then we have what? The error to be what? The error, it will be given to you in the question whether you have error or not. So if all these are 0, multiplying the x1, x2, and then s3, it will become what? 0. So it means automatically your dependent variable will be equal to what? The b naught, which is the constant or the intercept. If all or when all the independent variables are what? 0. We have the beta 1. So the beta 1, for example, let's say the beta 1 is equal to 0.15. So the beta naught we are explaining or interpreting. So a unit increase in dependent variable. What is the dependent variable here? The y will lead to an increase in the independent variable x by what? 0.15 what? Units. All other factors on hold. So this phrase is the same as all other things being equal. So if a unit increase in what? Dependent variable with what? The y will lead to what? Will lead to an increase in the independent what? Variable, which is what? The x. It means that since this one is what? Positive. So since it's positive, it means it will increase it. So when this y is increased by 1, our units here or our variables here will also be what? Increased by what? The 0.15. All other things on hold, or all other factors on hold. And then we have the next one, which is the beta 2. So the beta 2 example, we have negative 0.16. So the negative 0.16 we interpret it in the way that a unit increase in the a unit increase in the dependent variable, which is what, the y dependent variable. A unit increase, if this is increased by what, 1, it will lead to what, a decrease in the independent variable by 0.16 units. All other factors on hold. So this means that we have what, a negative figure. So it means if this dependent variable is increased by 1, it will decrease our what, it will decrease our independent variable by 0.16, because it's what, negative. So that's the explanation. And then we have the third step that we have to what, we have to talk about is testing of significance variables at 0.5 level of significance. So with this one, we follow what, we follow a process. That's the way we used to solve for the one sample t-test and also the two sample t-test. This is how we do it here. So when you solve for this question, it's the same as you go by the way, by what, using the one sample t-test approach. So here we have state the hypothesis. The first thing that we have to do is what, state the hypothesis. So the hypothesis, we have what, into what, beta 1 is equal to what, 0. So that one will give us to be what, null hypothesis. And then we have h1 into what, beta j, that is not equal to 0, and that will be our what, alternative hypothesis. So that we have stated our hypothesis already. So we have what, we have our decision rule, the rule that will guide how we make our decision. So that one we have what, state the significance, what, state the significance, which is what, the 0.05, and significance we use what, alpha to represent it. So we have, after stating that, then we have to find our t critical what, our t critical value. So the t critical value in the regression model, we have what, we have our alpha, which is what, the 0.05, and then we have our v1 and then v2. So the v1 and the v2, we have level of what, significance, which is what, this one. So the v1 is what, regression. It will be given to you in the question or in the Excel form. And also we have the v2 to be what, residual. That one too will be given to you in the what, in the question. And third, we have the computation. So with the computation, whenever you are doing multiple linear regression, the computation, this figure will be given to you in the Excel. So we have what, f statistics, or the value of f. That one, you just write the value of f or what, f statistics in there. Then we come to our decision. The decision, how we will make the decision. If our f statistics is what, is less than the t critical value, which is what, which is this one that we have what, we have solved for. If our f statistics, which is this, is what, is less than the critical value, it means the model is what, significant. But if our f statistics is what, is less than, if our f statistics is what, less than the t critical value, it means our model is not significant. So this is it. And then after making the decision, this will help you to what, make the decision. After making the decision, you have to explain your decision. So the decision, you interpret the decision by saying that the overall model, so this model, the overall model of what, this one, if our f statistics is greater than the t critical value, it means the whole model, the overall model is what, significant. But if our f statistics is less than the t critical value, then it means the overall model is what, not significant. That's the interpretation. And then the next step that they will talk about is statistical significance of variables. So with this one, we will use the p-values in the question. The p-values, if the p-value is what, greater than level of significance, which has been given to you to be what, 0.05, then it will be what, it will be not significant. But if our p-value is less than the level of significance, which is what, the 0.05, then it's what, significance or significant. So this is another what, step. And then we have the r squared. The r squared simply tells us about what, the things or the factors. So here we talked about what, the all other factors on hold. So the factors, we are talking about the factors that help us to what? Get all this model. So the R squared is what? Trying to tell us about the percentage that we use to get the model. So here we have what? The coefficients of what? Determination. That's what? The R squared. So the R squared will be given to you in the question, and then you what? You will state the R squared, then you will convert it into percentage. When you convert it into percentage, that will tell you the percentage of what? All the factors that was what? Involved in getting the model. And then we have the percentage of what? Variation. That is 1 minus R. Now, percentage, if you talk about, if you want a percentage, it's over 100. So the over 100 that we are talking about, here, the R squared will be given to you in what? In a figure form, which is 0 point something. So the 0 point something will represent your R squared. And when you deduct it from 1, it means you get the remaining percentage that is not what? Affected, or that is not part of this model. So this is what the multiple linear regression talks about. So we are coming to solve a question that relates to this for us to get to know how to solve a multiple linear regression. We have our question, which is last year's past question. So a bank is interested in predicting the credit card spending of its customers based on several factors. The bank collected data from a sample of credit card holders, including their annual income, age, and credit limits. The dependent variables is the monthly credit card spending, which is into cedis, and it has been represented by what? Y. And then using a multiple linear regression model with annual income, which is X1, age, X2 in years, and credit limits, which is S3, as independent variables. The following is the summary output of the fitted multiple linear regression model to the data. So the data has been given to you, and you have your multiple regression. We have R squared, adjusted R squared, standard error. We have observation. So the question has been given to you. The first question that we are talking about is, what is the multiple linear regression equation that represents the relationship between annual income, age, credit limits, and monthly spending? So the question has been given to you to state the regression, the multiple linear regression, and we have it here. Now, when you look at the question has been given to you. You see the Excel from the third one, which is the intercept, annual income, age, and then credit limits. We have the coefficients. So the coefficients is what we are coming to use to represent the what? The regression model. So the first thing that we have to do is to state our Y naught. So our dependent variable is equal to what? Our independent what? Variable. So the first one that you have to what? You have to write is the intercept, or the constant value. So when you look into the question, the constant value is what? 7.3155. So this is it. This is the intercept, or the constant value that we have in the Excel. Now the second one is what? Our X1. So the X1, we talked about something like this: beta 1 X1. So anything relating to what? X1 is what we are coming to write here. So we have the figure to be what? The figure is a positive figure. So we bring what? Plus 0.0188. Then we will attach it to what? Our X1. Now the second one is what? Or the third one is age. The age, it has been given to us in the negative what? In the negative form. So we state the way it is in the what? In the Excel form. So we have our negative what? Our negative 2.9996. X what? 2, because S is represented by what? X2. Sorry, age is represented by X2. And then we have the next one. The next one is what? A positive figure. So the positive figure will be given to us in the S3, which is what? Plus 0.0696 S3. So this is what? So when you state this, it means you are done with the first question, which is what? The multiple linear what? Regression model. So we have stated the model. And then the second question is of what? Income, age, credit limits, and what? Monthly spending. The second question is about what? Interpret the coefficients of the independent variables of the regression equation in the context of the problem. So in the context of the problem, we are talking about what? Our monthly spending, how people spend their money on what? Monthly basis. And they use what? Their age, they use their credit limit, and also their annual income to what? Determine the monthly spending. So this is our model that we have there. And then the second thing that we have to talk about is what? The interpretation. The question says that we have to interpret. So by interpreting it, we have our second question, which is what? The B. We are interpreting what? All this. So this represents what? The constant. And we always say that this constant is what? Is equal to the y naught, which is what? The dependence variable, if all this, which is what? X1, X2, and then S3, which represent the annual income, we have the age, and also what? The credit limit. If all are zero, then our dependent variable will be equal to what? The constant. So the first thing that we have to do is to what? Is to interpret. So if or when, so we have our B, which is what? 7.355, and we will interpret it that this is the value of the dependent variable when all the independent variables are zero. So this is it. If everything here, starting from here x1, x2, s3, all the numbers attached to it, if they are equal to zero, then it means our dependent variable is equal to what? The constant, which is the 7.3155. So the second one is what? Is annual income. So the second one we have to explain, which is 0.0188. So we explain by saying a unit increase in the dependent variable will lead to an increase in an increase of 0.0188 units, or 0.11 is in what? Cedis. So increase in what? Cedis of what? Our monthly spending, holding all other factors. So this is what? This is the annual what? Annual income. Now let's go to the age. The age has been given to us in the year. So we have the age to be what? 2.9996. It has been given to us like this. So we have a unit increase in the dependent variable will lead to a decrease of what? 2.9996 years in what? Of our monthly spending. all other things on hold. Now, let's the last one. So that one to we have what 0.0696. That represents what the credit limit. So we have our credit limit, which is what a unit increase in the dependent variable will lead to a an increase of 0.0696 cedis of our monthly spending. All other things on hold. So this is it. So right now we are done with what the interpretation. Now you see that we have what increase with, and we have what a decrease. Now this figure is what a positive figure, and we are saying that this is the value of what the dependent variable, which is what the y. When all the independent variables are what zero, the independent variable that we are talking about is what the annual income, age, and also what the credit limit, which has been represented by what 0.0188. We have negative 2.996, and then we have 0.0696. If all these are zero, then our dependent variable is just equal to what the 7.3155, and then the unit. The second one is what the annual income. The annual income is what 0.0188. A unit increase in the dependent variable, which is what the y, will lead to what an increase of what 0.0188 cedis of our monthly what spending, which represents what our annual income. And then we have the 0.9. So this one you can do it what negative. So negative 2.996, negative 2.9996. So a unit increase in the dependent variable will lead to what a decrease, because this is what negative. So decrease of what 2.9996 years of our what monthly spending, all other things on hold. And we have what the last one, which is the credit limit. A unit increase in the dependent variable will lead to an increase of what 0.0696 cedis of our what monthly spending, all other things on hold. So this is what the interpretation form. And then the next question is what is for us to test, which is the C. Test at the 0.05 level the significance of the model linear regression what model. So with this test, we are coming to use what the decision rule, or the steps in solving for the one sample t-test, for us to what decide, because we are testing. So we have to make a decision whether it's what is a significance or what is not. So the first thing that we have to do, so C, testing the significance of variables at 0.05 level of significance. So this is what we are coming to test for. We are coming to test whether the model is what significant or is not significant. So the first thing that we have to do is to what state our hypothesis. State the hypothesis. So our first thing that we need to do is to what is to write our hypothesis, which is this equal to 0, and then we have what h1 to beta is not equal to what? 0. So we have this. We have stated our hypothesis. Then next question is what? Our decision rule. The rule that will guide us to make a decision. Now, the first thing that we have to do is to what? State the level of significance. And the level of significance has been given to us as what? 0.05 in the question. And then we have to solve for what? Our T critical. Our T critical what? Value. So our T critical value. In the explanation, I said we have what? We have the alpha, we have the vein 1, and then we have what? The vein what? 2. So with this one, we have to what? We have to state it. We have to state it. And looking into the question, we have, as I explained earlier, I said the V1 is what? The regression. And then the V2 is what? The residual. So we have our A to be 0.05. And we have our V1 to be equal to. So V1 is what? The regression, which is 3. And we have our V2 is equal to 3 as well. So this is what we have. So our T critical value, critical will be given to us as 0.05, 3, 3. So you check the table that has been given to you in the question. So checking at the table that has been given to you in the question, you see that the first table, we have what? The alpha equal to 0.05. So we have 0.05. That's the table that we are coming to use. So we will check the 3, which is what? The V1, and then the 3, which is what? The V2. So you check the 3 on the horizontal, and then also what? On the vertical, which is the column, and then also the row. So the 3 to 3 will give us what? 9.28. So it means this value will be what? 9.28. So we have what? We have stated it. It's what? At 9.23. So the next thing that we are supposed to do is to compute. Is what? For us to compute. Computation. Now, as I said, the computation is simply means what? The F value or F statistics. So the F statistics, looking into the question, F statistics have been given to you. And the question, the one with the head and ANOVA, F statistics is the same as what? The F. And it has been given to you as what? 66.51. That's what our F statistics. Now, the third or the fourth thing that we have to do is what? Our decision. We have to make a decision. We are still testing. We have to make a decision. So the decision that has been given to us, what we have to do is we have to check our F statistics and the T critical value. Now, when you check the T critical, you see that our F statistics is what? Our F statistics is what? Is greater than our T critical value. Is greater than our T critical value. Then you state our F statistics is what? 66.51 is greater than what? The 9.28. So this means that our model is what? Significant. So since we have what? We have seen this, it means our model is what? Significant. So you write what? Significant. Now, the next thing is what? Interpretation. Now, we have made a decision. So we have to what? Interpretation. So we interpret it by, we are saying that it's what? Significant. So the overall model of regression is significant. This is the question C. So with the question C, we are done with it. So we are going to the question D.
The question D says that state with reasons which of the independent variables are statistically what significant. So the first thing that we have to do is what we this one we are going to use the p-values. So because of space, I will clean here, but I will leave here because I will use this one to solve another question. So the next question says that state with reason which of the independent variables are statistically significant. So with that one too, what we have to do is we are coming to use the p-values. So the p-values are what we are coming to use. And if our p-value is what is greater than, if our p-value is greater than the significance that has been given to us, then it means what is it means our level of what or our test will be what not significant. But if the p-value is less than the level of significance that has been given to us, then it means it will be what significant. So the question D, state with reason. So we have what question D. So we have what our p-value. So this one you can even draw a table because we are coming to test for all the three what items that has been given to us. So we have our variables. We have our variables, which is what annual income. We have age, and then we have what credit limits. Then you take our p-value, and then we take what our level of significance. So level of significance. Then we have what we have our decision, whether it's what significant or not. So we have this, we know the what level of significance has been given to us as what 0.05 in the question, 0.05, and here 0.05. And then we go to what we go into the question, the p-values that has been given to us. So the p-values, we have this one, you will see it in the what in the third Excel. We have the p-value at the corner there. So the first p-value is what 0.1367, and then the age p-value, sorry, this is the intercept rather. So the income one will be 0.0428, and then the age will be 0.6591, and we have 0.0085. Now, all that we are trying to say is if your p-value here is greater than the significance that has been given to us in the question, then it means the decision has to be what not significant. But if your p-value is less than the level of significance that has been given to you, then it means the decision has to be what significant. It has to fit the model, because the model has given to you as what the 0.05. So when you check these two figures, we have what 0, point. We have another 0, but the next figure here is what 4, but here is what 5. It means our level of significance is greater than what our p-value. So this will tell us to be what for this to be significant, because the significance figure has been what given to us in the question is greater than what the p-value. The p-value is what less than the level of what significance. Now let's go to the second one. We have 0. Here we have 6. Here we have what 0. So automatically our p-value is what greater than our level of what significant, which will make it what not significant. And then the third one, we have what 0.00, and here we have what 0.05. So automatically our level of significance is greater than what is greater than our p-value. So that one will give it to us as what the significance or significance. So the question says that with what with reason, So with reason, we can what? We can conclude. So we can conclude that conclusion. So we can conclude that all the independent variables to bracket what? So the significant thing that we are talking about, significance, which is what? This one is what? X1, X2, and what? X3, which is X1 and X3 is significant with the exception of what? Of X2. With the exception of what? X2, which is not significant. So this is it. We are done with what? Stating with what? A reason. So we have stated with what? A reason. Now the stating is, we have stated that is what? Significant, it's not significant, it's significant. Now the reason, as we can what? Conclude. Now this is what? This is our evidence. So right now we can what? Conclude that all the independent what? Variables with what? X1, which is annual income, and then what? S3, which is credit limits, is what? Significant, with the exception of what? Age, which is S2, which is not what? Significant. So we are done with what? The D part. So the E, if a customer has an annual income of 35,000 Ghana cedis, age of 40 years, and a credit limit of 9,000, what is the predicted monthly spending based on the regression model? So based on this, they have given our income level. So our annual income has been given to us in the question as what? 65,000 Ghana cedis. Our age has been given to us as what? 40 years. And then we have our credit limits. That one too has been given to us as what? 9,000 in the question. So what will be what? What is the predicted monthly spending based on the regression model? So based on this regression model that has been given to us, our annual income, age, and credit limits, if we are given these variables, what will be our monthly spending? So that's what we are coming to what? We are coming to solve for. So as I said earlier, I said I will need what? This model again. So this is what we are coming to do. So we have to solve for what? We have to replace all these figures in what? Remember, income is what? X1, age is what? X2, and then credit limit is what? S3. So we have to replace all these figures in where we see X1, X2, and what? X3. So we have what? We have our Y, which is what? The dependent, and then we have our the intercept, which is 7.3155. So plus 0.0188. Now it's multiplying by what? X1, and our X1 is what? Annual income, which is what? 65,000. Then you state minus what? Minus 2.9996. Our S2 is what? 40. And then what? Plus. So plus what? 0.0696. Our S3 has been given to us as what? 9,000. So we have what? Our 9,000 here. So we are coming to solve for this, for us to get our what? Our monthly spending, which is what? The dependent variable. So the first thing that we have to solve for is what? This. So we have this, which is not attached to what? Anything. Plus, then you multiply this and this. So on our calculator, we have 0.0188 multiplying the 65,000. And that one is giving us 1,222. and we have a negative 2.9996 multiplying the 40, and that one is giving us negative 119.984. Then we have 0.0696 multiplying 9,000. That one also will give us positive 626.4. So when you put all these together, we have 7.3155 plus 1222 minus 119.984 plus 626.4. That one will give us 1735.37315. So this is what our monthly spending, and it will be in what? It will be in cedis. So the one that we have it in the point form, which is what? The decimals. We have to what? Convert it into what? 2 decimal place. So with this one we have what? 1,000. So it will be given to us in the what? In the cedis. So we have what? 1,735 cedis. Then what? 73 what? Pesos. This is what? This is the figure for the what? For the question. So this is question E. Now we have our what? Question F. So the question F also says that question F, find the coefficients of determination for the regression model. What does the value indicate about the goodness of fits of the model? So the coefficients, as I said earlier, is what? The R squared. So we have what? The R squared. The R squared. So we have to what? State in the question, the R squared is given to us as what? So we have our coefficients of determination. So we have what? R squared. The R squared has been given to us in the question as we have 0.9852. So this is what? The coefficient. So after giving this, then we what? With what? The question says find the coefficient of determination for the what? Regression model. What does the value indicate about the goodness of fit of the model? So with this one, we can what? Convert it into what? Percentage, which is what? Which will give us 98.52%. So the R squared of 0.9852 implies that all the independent variables explains so we have what? 98.52% of variation of the dependent variable. So this is that the fit model, it means that 98.52% is what? implies that all the independent variables explains what 99. So all the independent variable, which is what our annual income, age, and what credit limit, what in our monthly spending, it will constitute what 98.52%, which is not up to the 100% of what our spending. So this is what it is. It fits what the model. So the J, also says that state or what percentage of the total variation in sales can be attributed to other factors apart from these three. So apart from what annual income, age, credit limits, we have other factors, because these three variables does not constitute what 100%. So apart from what these three, what is the percentage of what the other factors that constitute our what monthly spending? So what we have to do is we have to state, so percentage of what percentage of variation. We have our percentage of variation, and it is given to us as what 1 minus what r squared. So we have what 1 minus the r squared, which has been given to us as what 0.9852. So when you solve for this, you will get what you will get 0.0 what 148. So 0.0 what 0.0148. That one too constitutes what 1.48%. So other factors apart from what our annual income, age, and what credit limit, it will constitute only 1.48. So we are done with what that question 2. And the last question: conduct a hypothesis test to determine if credit limit is a statistically significant predictor of monthly spending. So this one, they are just what they are just telling you to what solve for this same thing, but the same thing is only limited to what credit limit. So you take your what credit limit. So the this is J. So our H, we have the credit limit. We are testing the credit limit whether it was significant or not. So credit limit, we have our credit limit figure to be what? We have our credit limit figure to be. So we have the P value of what credit limit, and it has been given to us as what 0.0085. And then we have our level of significance. So we have level of significance, which has been given to us as what 0.05. So with this one is what is the p value is less than what the credit what the level of significance. So we can say that is what is significant, because our p value is less than the level of significance that has been given to us. The level that the credit limit can reach is what less than, so it means it fits the model. So this one we can conclude that, so here is what significant. So we can conclude that the credit limit is statistically significant. So this is it. So this retesting for what the credit limit. So this is the question: multiple linear regression. It's not difficult. You just have to follow the steps. If you follow the steps, you get your 20 marks. And this is how the questions will be set. If you follow these steps like accordingly, you will get all your 20 marks. So with this one, I will explain the one sample t-test in it, because I use the one sample t-test in what solving for this similar what question. So with this question, if multiple linear regression has been given to you and you don't know how to determine or find for the one sample t-test, you are going to find yourself wanting, or it will be difficult for you to what to determine or to test for the level of what significance in the question. So with this one sample t-test, I want to explain something. So I'll clean here.
So we have one sample t-test. So one sample t-test.
Someone can ask, or someone may be asking, how, when you see the question, how will you determine whether this is what, one sample t-test or two sample t-test? Now, in the one sample t-test, we have three things that we use to what? We use to identify whether this is a one sample t-test. When the three things, if you find only one in it, it means it's one sample t-test. So the first thing that we will talk about is
Random
sample. Two, we have the mean score or rate, mean rate. And then three, we have what? Assume normality.
So with these three,
If you read the question about the sample t-test, for you to understand or for you to identify or determine whether it's a one sample t-test or two sample t-test, you have to what? You have to find at least one of these in the question. So we have what? Random sample. If you see random sample, it means it's what? One sample t-test. And if you see mean score will be given to you in what? In a figure form, let's say 45. Mean score. And then we have what? Or mean rate. The rate will be given to you in what? Percentage. Let's say 50 what? Percent. So if you have this, it means what? One sample t-test. Mean score and mean rate, they are what? The same thing that is the same thing that we can use to determine a one sample t-test. And we have assume normality. That one is what? Given to you in the question. Assume normality. You have to what? Decide. So about one sample t-test, we are just deciding or making a decision whether this is what? This is a significant or is not what? Significant. So that's what it's about. So I have a simple question here that I want us to solve. And I will teach you a certain techniques about it. This question. So we have listed below is the annual rate of returns reported in percentage for a sample of 12 taxable mutual funds. So the first thing, you can even identify one of these. So the first thing, the listed below is the what? Annual rate of returns. Annual rate of what? Returns. So rate, you have found what? The rate.
and the table has been given to you, which is what? 4.63, 4.15, 4.76, 4.70, 4.65, 4.52, 4.70, 5.06, 4.24, 4.51, 4.24, and 4.52. Using the 0.05 significance level, is it reasonable to conclude that the mean rate of return is more than 4.5%?
So the mean what? Rate. You have seen another what? Mean rate. Mean rate is what? Also here. So one sample t-test. Assume normality. The mean score and standard deviation were as follows. So assume what? Normality. So this question has been given to us in what? And then we have our mean score. So we have the sample, and then we have what? Our mean score to be what? 4.572, and we have our standard deviation to be 0.241. So this is it. So having this, we have to what? The question is saying that assume normality. The mean score, the question is saying that using the 0.05 significance level, is it reasonable to conclude that the mean rate of return is more than the 4.5% that has been what? Given to us in the question? So the first thing that we are supposed to do is to what? Is to state our hypothesis. So the first step one, we have what? State the So we have state the hypothesis. So the hypothesis we have what? We have H0 to what? The mean. So the mean or the mean rate. So the mean rate we use what? This symbol to represent it. You understand? And it's equal to what? 4.5 what? Percent. And then we have what? We have our alternative, which is what? The mean rate is what? Greater than the 4.5%, which has been given to us in the question. This is what we are coming to what? See whether it's what is greater than the 4.5% or less than the 4.5% for us to conclude. So we have what? Stated our hypothesis. So the first thing that we have to do is to what? There's another step, which is the decision rule. What will guide our decision rule? So decision rule, first thing that we have to what? We have to do is to find our T critical value. And with this one, if you are finding for the T critical value, since you have been given what? You have been given only the level of significance. So the level of significance is equal to what? So it's what? Alpha equals what? 0.05 in the question. And with this one, we have to what? State our what? Our degree of what? Freedom. So our degree of freedom is given to us as what? The n, which is what? The number or the sample minus what? 1. And this one will be given to us as what? We have what? The n to be 12 minus what? 1. So this one will be what? 11. So we have what? Our degree of freedom to be what? 11. We have our degree of freedom to be what? 11. So we have our degree of freedom to be 11. So the next thing that we have to do is what? Is to get the T critical what? Value. So T critical. We have what? The level of significance, which is what? 0.05 and what? 11. So how are we going to what? Get it? So in your table, we have what? We have the T distributed table. It will be given to you in the question. And then you will find for what? The 0. What? The 5. So the 0.5 will be at the top like this. If you have the table, it will be like the 0.05. And here they have 0.025. And here we have 1, 2, 3, up to what? Up to 11. So with this one, you check the 0.05, and then you correspond it to what? The 11. So it will be here. This portion. So this portion, the answer that will be given to us is what? 1.7 what? 796. This is what we will get. The T distribution what? Table. This is what we will get. So after getting this, what we have to do is we decision rule. So we will reject the what? Hypothesis. So the hypothesis, if T value is what? Greater than or equal to 1.76, and then we what? Accept or retain the what? The hypothesis. If T is what? If the T critical is what? Is greater or less than. If the T value is what? Less than the is less than the T critical value. So if our level of what? Significance is less than the T what? The T critical value, then we what? Retain or accept it. But if it is equal to or greater than, then what? We reject it. So the next one that we have to do is what? Step 3. Step 3, which is what? The computation. Now, the computation, you see here, you have given what? The n, which is the sample. We have given the mean and also what? The standard deviation. Now, the computation, we state what? the so we the test statistics. So it's given to us in what? In this way. So we have our mean minus what? Our rate, normal rate over what? Standard deviation over what? Our sample space. So this is what? The formula. Now, after solving for all this and all the questions, I will teach you the simple form to what? Or the short form to find for the what? To find for the sample space and then mean and standard deviation if the question is not given. If the question has not given you all this, how you what solve for it using the calculator and also using what the normal thing. So the first thing that we have to do, this one we have been given what the mean, which is what 4 points. So we have the mean to be what? We have 4.572 minus the what? The mean rate. Now, the mean rate was given to us as what? 4.5%. Now, in one sample t-test, we don't change this into decimals. We only remove the percentage. We only remove the percentage. We don't change this into decimals. So, we have our 4.5 all over. Standard deviation has been given to us as what? 0.241 and then over what? The sample space there. Square root of what? The sample space, which is what? 12. So after solving this, you will get what? You will get 1.035. So this is what you will get for what? Your t value. So we have what? The t value. And we have what? The critical value also there. So we are done for the computation. The next thing that we have to do is to what? Make a decision. So step 4. Step 4. Decision. So we are making a decision. And our decision rule. We have our decision rule. Decision rule. So we have to what? We reject the hypothesis if the t what? The t value. Where is the t value? The t value is what? Is this. Is what? Greater than or equal to this value, which is the 1.7 what? 96. And also we what? We will retain or accept the hypothesis if the t value is less than what? The 1.796. So with this one, you will state we have the t value to be what? So we have t value to be 1.035 and we have the t critical value, which is what? 1.796. So it's what? It's less than the what? The t critical value. So it means we have to what? We have to accept the what? Hypothesis. So since the t is less than what? It's less than 1 point this, we retain the hypothesis at what? 0.05 level of significance. So we have made a decision and we have to what? Explain. So step 5. Interpretation. So we are saying that we what? We will retain or accept the what? The hypothesis at 0.05 level of what? Significance. So we have to interpret. So interpreting, we say at 0.05 level of significance. There is not enough evidence to conclude that average annual rates
of returns is greater than 4.5%.
Now, with this interpretation, all that the question is saying is we have to test or make a decision that the model that has been given to us, or the significance level that has been given to us, is it has a greater returns of rates than the 4.5%. So after testing, if you reject in the decision rule has been given to us like this. If we reject the hypothesis, it means it's greater than what the question is given to us as the mean rate. But if we accept, it means it's less than. So when we conclude, we had the t value to be 1.035, and we have our t critical value to be 1.796. So with this one, we can make a decision that since the t value, which is this, is less than the t critical value, it means we have to accept. So we are accepting we are accepting the model. So since we are accepting the model, it means it's not greater than the 4.5 rate of returns. So we don't have enough evidence to conclude that average annual rate of returns is greater than the 4.5. So this is the question. So if you know these steps, it's easy for you to do the multiple linear regression. And if you don't know this, it will be very difficult. So these steps is just simple. First, you state your hypothesis, which is this. It will be given to you in the question. Second, decision rule. So level of significance will be given to you in the question. Mostly you will see 0.05, and it is represented by the alpha. And then degree of freedom, we will subtract 1 from the sample space, which is the sample space here was 12. So you subtract 1 from it, which is 11, for you to get your t critical value. So we have 0.05 and 11. This is what we use to find our t critical value. So if our hypothesis of if we have to reject our hypothesis, if the t value is greater than or less than greater than or equal to the t critical value, this is it. But we have to accept or retain the hypothesis if our t value that we solved here is less than the t critical value. So after solving for this, we had our t value to be to be less than the t critical value, which is the 1.796. So since the t is less than the 1.716, we retain or accept the HO, which is the hypothesis, at the level of at the level of significance 0.05. So it means we have accepted the model, we have accepted the question. And the question is saying that can we test that this mean that has been given to us is the model will be given to us, or will give us a greater mean rate than the 4.5. So at level of 0.05 level of significance, there is not enough evidence to conclude that average annual rate of returns is greater than the 4.5%. Now, I said in most of the questions, they won't give you this straightforward. So if you are not giving this question straightforward or this answer straightforward, you have to you have to solve for it. And you solving for it, we have we have how to solve for it. So the t value is given to us as the mean minus the original rate. And then we have over samples, the standard deviation over the square root of the sample space or the sample. So what we have to do is we have to find for the mean. And finding for the mean, it means you have to get the summation of x. Now, the summation of x means you have to you have to add all the things that has been given to you in the question. So 4.3, 4.63, we have 4.15 up to 4.52. That one will give you 54.5 86. And then we have what? You have to find for what? The x summation of x squared. So with this one, we have what? This squared. Or you can solve it and write the main figure plus. We have this squared. That one too will give you 251.438. Now, the mean here is given by 1 minus n multiplying what? The summation of what? X. This is it. This is the formula. So the formula, the mean will be given to us as what? 1. N is what? N is 12. It has been given to us already. Multiplying what? The summation of x, which is what? The 554.86. And that one will give us what? Will give us 4.5716666.7. So you run it into what? Into so the question was given to you in what? 3 decimal places. So when you run it, you have 7. Now this one is what? More than 5. So you remove 1 and what? Add it to this. So here the 1 will become what? 2. So in the question you see that you have what? Your mean to be what? 4.572. Now let's talk about the standard deviation. Now the standard deviation, we have what? This is the formula. We have 1 minus n1 multiplying what? Multiplying this, and then minus 1 minus what? 1 over n multiplying what? Summation x squared. So this is it. So we have our x equals what? 1 over n is what? 12 minus 1. And then we have our what? Summation x squared. So that one will give us what? 251.438 minus, don't bring any square here because the square we have what? Found for it already. Is this one that we have replaced it here. So you don't bring any square there again. So we have what? 1 over what? 12. And then we have what? Summation of what? Summation x, which is what? The 54.86. And then that one, the square is outside the what? Outside the bracket. So this is it. And when you solve for this, we have what? So we have 1 out of 11, 2, 5 points, minus 1 out of 12. And then this one will give us 3009 points. So the square is here, 0.6196. So this is what it will be given to you. Then you have our x squared, and this whole thing will be given to you as 0.05785151515. And then what? We find the square root of this because this is square and standard deviation is not what? A square. So we will do square root of both sides. And when you do square root of here, this will cancel this square root. So we get what? Only x. So the square root of this, and the square root of this will be given to you as 0.24052349191. Now you have to change it into what? You have to change it into 3 decimal places. So the 3 decimal places, we have what? Our standard deviation to be 0.24, and here is what? 0. Here is 5. So we what? We will add 1 to this 0 because in 3 decimal places. So we add 1 to it. So in the question, the standard deviation was given to you as what? As this. So this is how you find for what? The standard deviation and then the mean. And with the calculator, when you want to use the calculator, we have a method of what? Using it. Now, the first thing that you have to do is to press your mode. When you press your mode, then you go to the start, which is the 3. Press the mode. The first step, press the mode. So let me write it here. Maybe because of time, the question has not given you the standard deviation and also the mean. And because of time, you can't use this step to solve for it. So what you have to do is you press, so the first step, press the mode on your calculator. 2, select option 3, select 3, which is what? The start. The start. And then the 3, select 1, which is what? The 1 minus what? The var, var. Now, step 4. Step 4. Type all the what? X values in the X row, sorry, column. So you see where you have been given the X, the X value was given to you, the 4.2, the 4.5 to 4.24. You have to what? You have to type it orderly in what? In the X what? Column. And when you type it 4 points, let's say 51, then you press what? Equal to, it will move you to what? The next one. So after everything, after punching everything, then you what? So you press 5, press the AC on the calculator. So after the AC, then you what? You press shift. So you press your shift. So after pressing the shift, then you do what? After pressing the shift, you get what? 1. So you select what? 1, which is the start. Which is the start. So shift plus what? 1. Shift plus 1. Then the first step is what? Select 4, which is also what? The var, which is var. The var. And then 8. What you have to do now, you see something will be given to you in what? 1, 2, 3, and 4. Now you will get what? A certain symbols that has been given to you. 1, 2, 3, 4. Remember, the first thing is what? Is your sample. So if you point this into your calculator, you get what? You will get the 12 that has been given to us in the question, the sample. Now the second one will give you what? The mean. The mean has been given to us in the question as what? As 4.572. And then you see this fourth will give it to us as what? The standard deviation. So this is the short form or the calculator approach to find for the sample space, the mean, and also the standard deviation. And this one, you use this method only when you don't have time to solve for the question. But if you have time, you have to use this. You have to show working for everything. So this is the end of our video, and I hope by going through all this till the day that you write the exams, you'll be able to answer the one sample t-test and also the multiple linear regression, because if you can't do the one sample t-test, it will be difficult for you to solve for some of the questions, especially with the test. That one holds the highest mark in the multiple linear regression. So if you can't use this, it means you are going to use a lot of marks there. So by learning this, you will be able, or you will be finding it easy to solve for the linear multiple regression. So this is the end of this episode of IX tutorials. As I said, my name is Prince Owusu, a level 200 business admin student, and I wish you all the best in your exams. Bye bye.